This is Preuss from Kaspersky. He will introduce himself very shortly, and he's a great guy, and Kaspersky is one of our sponsors. And Marco has been with us for several conferences before, and of course he never fails to bring really interesting talks to PasswordsCon, as he will do today as well. So good luck, and give a applause for Marco.
Thanks, Per. Yes, I'm Marco. I'm working with Kaspersky and GREAT, the Global Research and Analysis team. So we're a globally distributed team of analysts and researchers working on a lot of interesting topics. About myself a bit, principal, as Per said before, I've been here, I think it's my third talk at PasswordsCon, so Vegas and also in Norway. And in principle, talking about passwords is something interesting, but in principle, there's a lot of things which brings me up at night, or wakes me up in the morning, let's say it this way. First of all, I'm a research guy interested in threats, so my main job and also my dedication is, of course, fighting the bad guys, helping the good guys, and taking care about everything what's going on. And one of my very special interests, private and also business, is of course something which also brings me up at night every now and then, the question of passwords, because it's so central to our today's life, but also in the past. And as I'm a guy interested also in things in IT security and in computers for many years now, I just want to start a bit in the past when it comes to passwords. And exactly in 1973, so just 41 years ago, not 42, sadly, there were the mainframe systems. So this is, for example, a UNIVAC 9060 system, which was used in a lot of universities. Maybe here's a more interesting picture. And these machines were used in mostly universities or big corporations worldwide, in US and Europe and so on. And even there, these questions arose with passwords, of course, because on these systems you had many, many users. Not everyone had his personal computer or notebook or smartphone or whatever, but you had one big central machine, and a lot of different people just got access to and worked on these systems. So I just read a bit in the internet, and yeah, see, at one university, for example, they had their own kind of policy, how they created the default passwords for all the people just going there, which was the birth date of these people. So maybe not the most maybe not the most wise thing to do. And in general, all these mainframes from this particular area had these limit of max 8 characters and very limited set of features, of course. But still, most of the today's computer areas are designed in that way from back of the 70s and 80s and whatever, where people with white coats were standing in front of big machines, handling all that stuff, all that security things, and the normal user had nothing to do but just log in and do their stuff. And switching from the past a bit to the future, I don't think that these question of authentication, and especially passwords, passphrases, PIN codes, whatever, will just drop, because many, many new funny things will come up, like the Internet of Things, where all kind of different devices, like also my watch and smartphones and even my stuff at home, will be connected to the internet somehow. And there will be a lot of there are and will be more cloud services and all that stuff, handling data, storing data, so you don't have everything local anymore, but everything is somewhere. And to access your own data, you of course need passwords, right? From that, coming to today, there is the phrase I had in the title of my presentation, "Do cats like lemon?" This was just some phrase which come to my mind because I like cats, of course, and lemons is also something interesting. And for everybody interested here in this question, spoiler alarm, cats don't like lemons. But why this phrase? I mean, that's quite interesting because also dogs don't like lemons. But anyway, why this phrase? I looked a bit around, reading all that news and all that stuff. And I came, for example, to this thing. Maybe some of you in this audience know this. Like, oh, creating complex passwords, easy to guess, hard to remember. So let's do something better. Just combine some common words and make it hard to guess and easy to remember. And also on Lifehacker, they had this article about that stuff, like the type of password, method, how it can be solved easily, and what period of time, and the security level. So when I just have a look at the last one here, this is fun. More than 2,500 years. Interesting. Okay. Of course, I'm always talking with people, and a good friend of mine came to me and said, hey, these password phrases, that's something interesting. We need to have a deeper look at that because there are many tools out there getting into this area like brute forcing and rules and complex password cracking and so on. But what about password phrases? Words just combined used as password. And one thing in this area you have to keep in mind is for the common passwords we already know, people are lazy, so they use their stuff which is easy to remember, like pet names, like when you have a cat, you just use cat or the name of your cat or something else, like easy to guess stuff. And maybe lazy people will just also use this stuff when it comes to password phrases, just common stuff which they know. My cat is named Lemon, for example. So how hard is it to guess this kind of password? And after thinking about all that stuff, of course, I like coding a bit, and I created my own tool for making a bit deeper research in that area. But before, of course, when creating or generating or trying to do research in that area, you need some backend. And I will start with that, my tools. When people use or want to use password phrases, they normally will use some common phrases. And I created just some small crawlers going on some websites, like Reddit, Bildschirmarbeiter, which is a German website. I don't think you know this. And also parsing IRC logs, because this is also interesting, to get just a lot of common sentences and text files, what people and how people are writing. So I don't use books, for example, because they're more artificial. It's not the common language people use and how people think. So I wanted to get to the real stuff. And when I just, for example, here you see that's just common stuff, how people write. They have their own things, how they shorten words and how they rephrase words and how they combine stuff. So I created me this small toolset as a basis. So based on that, I thought, okay, I need to make sense out of all that stuff. I have now tons of text files with words and everything, how to make sense of all that stuff. So I stepped into creating a database. Why a database? What for? In principle, what I'm doing here is what you maybe know from Markov chains, what's already there. Like the common Markov chains you have in password cracking tools are based on characters, like how often is one character used and followed by which other character. And in principle, I'm doing the same, just with complete words. So I'm parsing all these text files, setting everything into a database, storing the frequency of the words, or how often it occurs in a text, and then which words follow after a base word. And this also with frequency stored. I made it a bit more interesting for me because these common text files are messy. So I created stuff like how new lines are handled. If there are comments, for example, a new line doesn't have any relation to the line before, because one line is one sentence, of course, makes sense, as you would get trash, which doesn't make sense at all. How these words are splitted, because not everybody is just splitting with a white space, but something else. Words must be cleaned because you may have some numbers, uppercase, lowercase, some lead stuff inside which just need to be removed. And I want to be a bit flexible, so extension of all that stuff I show you just in a minute. And one very important thing, I don't use with my tools stop words. This is something what you normally read when handling, parsing, working with text files. You have a list of stop words you don't want to use. But in principle, these stop words are also words people may use in phrases. So I don't clean out any words like the or he, she, whatever. I leave them all inside to have the full relations. Yes. I think it's this one. Yeah. Let's put this here somewhere. Okay. In principle, let me just show you first the config file, which is maybe interesting, to show you what's behind all that stuff. I personally like writing my config files directly in Python, so I'm using Python for that stuff because it was just easier to write. So I'm writing everything in Python itself, all the configurations, because it's easier then to handle, and I avoid all this parsing stuff because I have my own library checking all these configurations so that it doesn't go messy. And here you see this stuff, what I mentioned before, like respect new line, if that's interesting, how to split words, if punctuation, non-printable characters should be filtered out, if numbers should be cleaned out, and also stuff which is also interesting. Some people like to write everything in uppercase to shout in the internet, or just lazy people write everything in lowercase. So you need to somehow think about this and think how you want to use it in your database for creating phrases. And I just have this here. First I want to create my database, and I use my tool interest comments. Nah, this screen is a bit messed up. So, okay. In principle, I just read in the comments from Reddit in this example. And it gives me, in this case, I have a limit of how deep I crawl this website of 7,800 unique words, which are now in my database and can be used. The extension was something I created because when I just want to add something new, I don't want to create every time a full database again, and it takes time, blah, blah, blah. So I just created this extend, just inserted the Bildschirmarbeiter, which doesn't make sense in this case. It's just as example because Reddit is mostly English, Bildschirmarbeiter is German, so there are not many mix-ups here. And you just see that I increased the count of the words, of the unique words, to more than 9,600. With this database, which is a bit complex, I like to visualize it a bit. People who know my past presentations know that I like visualizations, so I did it for this database too. And here are the word frequencies, so you clearly see especially the stop words like the, in, with, is, and so on. And the thing which is more interesting are the relations, which look a bit like this. So you can just, you cannot read it, of course, because the image is much larger. But every dot here is a word, and with the lines you can see the relations to other words. So one word followed by another word, followed by another word, followed by another word. And for all these transitions, I store, of course, the frequency to make it easier when generating phrases. Which brings me exactly to this point. Here, this is really interesting. To the config again. Store disk, this is something very important, just to note if anybody is interested in going to that area. The amount of data is really big over time, especially when generating all that stuff. Depends on the levels. I'm directly writing everything to the disk because the memory will exceed within a few seconds. The work mode strict I explain in a bit. And then on generating based on the database, I have several different kind of settings to use. First, this is incremental, which is just an interesting feature. Like if you want to combine several words, do you want to follow every step? Like in your output, you want to have word 1, then word 1, word 2, word 1, word 2, word 3, and so on, or just the final thing, word 1, word 2, word 3, word 5, and so on. The exact phrase is as commonly in Markov things defined with the threshold and length. So the length defines how many words are combined together from the transitions you have, and the threshold defines the priority of the words, to what extent the words should be combined. Another nice feature I added is the fourth length. So for example, if you have for one word not enough transitions to create like a 5-phrase combination, the most frequent words from your database will be appended to have the full length of 5. And I also played a bit with all combinations and permutations, which just means that the structure of the combinations are flexible. So the words are first in order and then mixed around within the output to have a broader image of that stuff. How does look like? Wait, there's one more. Yes. Oh yeah. Additionally, this is for the, there are some basic rules, how these words are combined, like with some split character in between, and also how many characters from a word should be appended, combined. Because normally people may use the full word, but they also may use just the first letter of a word, like the do my cat, no, do cats like lemon, DCLL, maybe for example a phrase, because it's just the first letter of every word combined together. And this is a setting which I also implemented here to make it a bit more flexible. For the mode which I had before, this is an interesting thing. I have in principle 3 different modes implemented how to create phrases. First is creating phrases on the database by itself. So every word in the database will be extended to the common phrases, which may sound interesting and may be worth trying. A second mode is to extend a given dictionary. So for example, if you have RockU, you just use RockU, and every word from RockU will be checked against the database. And if the word is in the database, it will be extended by the known transitions. So if there are real words in RockU or in your dictionary you feed in, they will be just extended to the natural relation what they have to given words in the database. And the second mode is a bit more complex, to combine 2 different dictionaries. So for example, if you give the RockU as base dictionary and a completely different dictionary as for extension, the words from the extension dictionary will be created and appended to every word from the RockU. So to have the RockU, for example, the RockU word, and then all the combinations based on the second dictionary to make it even more complex, which is really fun. In my example, I just used the I just created a small subset for RockU of 100 entries to make it a bit faster. And then the output for 2 look like this. Writing with one hand is a bit. So this is, for example, for RockU. So you have the base word, which are the first 2 characters. And for every word which is in the database, just the first 2 characters appended. And I just skipped the incremental, so this is the full length I want to have. Looks quite random, but there is really a meaning behind that. Okay. Yeah, that's what I mentioned. Different modi, incremental outputs, threshold and length plus force, and the and the advanced combinations. Another thing I had a look at was based on these database analyzing phrases from stuff you have. So for example, if you have a list of hashes, for example, and you just solved a few of them, so you know in which direction it may go, you could just paste it into and use your created database in order to make sense of the stuff you already know, to know which area to follow. So I added this to analyze. In this file, I just added two things, this and this is fun, which is the example from Lifehacker, to just show the potential behind that. So the word this was checked against the database. It's not a phrase because it's a full word known in the database. And this is fun from Lifehacker, for example. This is known, appears 344 times. So this is the occurrence in the raw text you parsed for creating the database. Is a transition, is a known transition of this with a frequency of 13, so 13 times, which is quite high. Is this followed by is? And fun is again a transition of is, frequency 1. So in one from all that cases from your raw data, fun is followed from by is followed by fun this way. So you know that this is a full transition you have here. This is fun. So you just may use your dictionary, your database, in order to generate just all that similar stuff. So it's full words, so you don't want to strip characters to a given set. You just want to create the full words from your database out and just let it run against your lists, and hopefully you have fun. Something what I noticed in several leaks which are known, you have already these kind of phrase combinations, but sometimes followed or prepended with numbers. And this, of course, you can just easily solve with any like OCL hashcut or whatever, with append and prepend rules to just add numbers to the given thing. And then you have a new source of input for your project you're running. For analyzing, I already have code, but I haven't implemented it yet because it's not fully tested. I also plan to use n-grams, different distance algorithms, and I also have some stuff more, like entropy checks and stuff, for doing even more deeper analysis from given phrases against the database, to make even more sense out of the stuff you already have, to find new maybe patterns and all that stuff, to be a bit more efficient. And I also wanted to extend the rule generation for the phrases in order to be a bit more flexible in what your output will be. So I'm nearly out of time. Just one thing left to say: be awesome and fight in the good direction. And if you have any questions, just ping me. I'll be here around, and also at DEF CON or my Twitter handle. Just drop me a note. And yes, currently, just to take this question before, I currently don't plan to release that tool yet, because once I haven't implemented everything yet, what I wanted to have for analyzing, and also I wanted to play a bit more with that stuff. And let's see if in Norway at the next PasswordsCon I give a next talk or an extended second talk on this topic. But if you have any question in that area, just come to me and we talk about it. Thanks.